is going to be recorded simultaneously. Okay, now this would be even if the projector cuts off, it's still recording. Hopefully the projector won't cut off. All right, y'all are here for Physics 112, right? Okay, that's Principles of Physics. Now, the primary reason for the course is for the sonography program, and I take it that at least a few of you are in that, right? And the other two of you are baseball players, right? Okay. So y'all are just taking it as a science elective? Okay, now, this doesn't count in Area 3 because it doesn't have a lab, but I guess it counts for you in Area 5. Is that right? Yes, sir. Okay. So y'all are okay with it? Okay. The rest of you are all sonography, or you take it as a science elective? Okay. All right. Okay. It's only a 2-hour course. That means that's because there is no lab. That's why we only meet 1 day a week for 2 hours. Okay? Hopefully we'll get started sooner than this because we almost lost 20 minutes already just because of the projector problems. Okay, and we are meeting Wednesday, 4:30 to 6:30 here on Birmingham East Campus in the K103. Now I have, y'all are probably aren't the ones that asked this. The sign out front says it's the Ethel Hall building, the L building, and yet here it's the K building. So I don't know. Is that what it always is? I don't know. Okay, it just doesn't make any sense to me. But this is I don't know. Okay, here's my information. My name's Charles Fowler. 4 days a week until I come over here. I'm on the Bessemer campus. And if y'all are familiar with the Bessemer campus, the big building kind of that's the center of the campus is the A building. And I'm in room 265. That's my office. Here's my phone number for my office. And I warn students, don't call and leave me voicemails because my voicemail is not working well. I sometimes can get messages, sometimes can't. So don't call thinking I'm going to get the message. I may not. I may get it, but I may not. So I say don't even bother to leave one. Otherwise, you'll get frustrated that I never return a call, but that means I never got the call. Now, my email address is cfowler@lawsonstate.edu. And by the way, that's for most of the employees of the college. First initial, last name at lawsonstate.edu. Now, we do have a number of people whose last name is Williams, and a few of those first initial is S, for instance. And so some of them have to have different things, like a middle initial in there as well. We've had a Martin that way, too. Ms. Martin has to use S.D. Martin because there was another Martin, S. Martin, here at some time or another. So there are occasions that you'll have something other than that. Mr. King, for instance, he wanted something different. He has Calvin underline King, and that's his at lawsonstate.edu. So a few people have different things. Most of us are first initial, last name. Okay, these are not my office hours because I haven't had a chance to update the syllabus. I'm the math department chair, and the last week has been nothing but hectic in canceling classes, calling students, telling them this class has been canceled, moving them from class to class. It's just been horrendous. So I haven't had a chance to update my syllabus. May have an opportunity tomorrow. I hope that will be the case. I believe it will be. And then Friday, I'll probably have some time to work on it. Whether it gets on Blackboard, I'm not sure. Maybe Friday. I don't know if I'll be able to get it there tomorrow or not. Let me go and explain it now. My wife has an outpatient surgery tomorrow. And I don't know if y'all are familiar with outpatient surgeries. They require you to have a family member or somebody in the waiting room at all times. You can't go and leave. You can't leave a phone number. You have to be there. Okay. So I have to be there tomorrow. I want to be there anyway, but there's no leaving. Okay. And I think she said hers was scheduled very early, meaning I think we get there at 5 o'clock in the morning. That's a joy. And so I might be sleeping a lot tomorrow rather than working on syllabus. But I hope I'll have some time that I'll be able to work on it while that's going on. If she gets there early, maybe they'll finish early. But then depends on how she's doing. I may need to stay home just in case anything goes. So I probably won't be on campus at all tomorrow, but maybe that means I'll be able to get some of this done. But I may not be able to access Blackboard from, it's the UAB Highland Hospital is where she's having outpatient surgery. So I'm not on campus tomorrow, but I will be back, as far as I know, on the Birmingham West campus on Friday. Okay, so here are my office. Oh, and that's why B122 on the Birmingham West campus, that's the academic building. Are y'all familiar with that one? Okay, it's Dr. Pruitt's office suite. It's that end of the building, toward the baseball field. Yeah, right before you go down, that room right on the left there. When you're coming up that set of steps, you step on the first step. The last step is right there on the right there. And that's B122. Now, his secretary's desk is right there when you go into the suite. His is the big corner office. Behind the secretary's desk is the copy room. That's my office on Fridays, okay? And there is a phone in there. It's 929-6409. However, please don't leave me a message on that phone because it's not my phone. That belongs to the a grant coordinator, a project coordinator, Monday through Thursday, but she's not there on Friday, so I use that office on Friday. And so if you leave a message there, it goes to her voicemail, and I never hear it, and she won't know what to do with it. So don't leave a message on this number ever. That one is really not good. So on both of those, only call during my office hours, and if you don't get me, then hang up and try again later. Don't try this number at all tomorrow. I won't be there. Okay, I'll be elsewhere. And my email address, of course, is that. Now, I'm behind in emails now, too, because I've been doing nothing but schedules all week. So at some point, I'll get around to doing emails again. Someone emailed me from this class. I saw it up there, and it said Physics 112. Well, I didn't get a chance to open it because some other student came in, and I never got back to it. But it wasn't any of you. Hopefully not. Okay. Office hours. Now, these are from last term. I will tell you what they are this term. And they may still change again. They changed this morning. When I came in this morning, I had 10 classes this term. And it was ridiculous. Okay. But this morning's class, I taught my first class, and then an instructor came in who was short of class, and I said, "You want this one?" And he said, "Yes." I said, "You got it. Take it, Toyota." Okay, so he got that one. So now on Mondays and Wednesdays, my office hours are 8 till 10. I had a 8:30 class. Now I don't, so it's 8 till 10. And on Mondays, I have office hours again from 3:45 to 6. Okay, so 8 to 10 and 3:45 to 6. Now, on Tuesdays and Thursdays, I have an 8:30 class, a 10 o'clock class, an 11:30 class, and a 1:15 class. The 1:15 class is a mini-term science course with a lab. That means it goes from 1:15 till 3:45 the class, and then 3:45 to 5:45 the lab, both Tuesday and Thursday. And so I'm in class all afternoon. So my office hours on Tuesday, Thursday are 8 to 8:30 and 5:45 to 6. So not many office hours there at all. I'm in the office at lunch. Let's see, what time is that? 11:45 to 1:15. No. 12:45 to 1:15. 12:45 to 1:15. 30 minutes lunch. So I didn't put that on there, but I usually will be in the office then. Wednesday now is just like Monday, except it's only 8 to 10. Why? Because 3:45, I'm packing my bags from my last class, getting in the car, and coming over here for this class. So I have very few office hours there, so I don't even list it. Last time it was 2 to 4 because I left at 4 to come over here. Now it's not. It's 3:45 to 4 would be all I could list, and basically then I'm just getting ready. Today I had students from the class that I was just finished. They were up there asking me, "I can't get my schedule changed. I need this, need that." And they say, "I know you got to go, but blah 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 blah." I gotta go. So I was late leaving. So sorry about that. Thursdays, most Thursdays, just like Tuesday, 8 to 8:30 and 5:45 to 6. Fridays, 8 to 12, and that's here on the Birmingham West Campus. Okay. Here's the course description for this course. And again, this course is designed for and set up for the sonography program. Okay. Get this thing go as far up as I can without going, whoa, yeah, there it goes. This course introduces the student to the basic principles of physics with an emphasis on electricity and magnetism. Okay? Now, they say that, but then when they list what you have to cover, it covers a lot more than that. And I don't see anyone with the text yet, but when you do get your text, now I hear they're expensive. Sorry about that. The only reason I'm using this book is one of the other schools that teaches sonography. It's either Wallace, Hansel, is that the one? Huh? And Gaston State. Okay, the only one that we, in the two-year college system, is Wallace and Hansel, right? Okay, and they offered it first, and we said, well, what physics book you use? And they said this one. So we got it, and since this seems to do the job for what they need, we're keeping it. Don't particularly love the book, but... It's not Cengage? What's that? So it's not Cengage? It's not Cengage. No, it's Pearson.
I ordered mine off Amazon for $30. I rented it.
Yeah, renting is much cheaper. What's that?
I was trying to see if it's on Cheeks.
On what?
Cheeks.
Oh, yeah, right. Okay. My hearing is really bad, so when you're talking, if I don't hear something, it's me, not you. Okay. Okay. So they say electricity and magnetism. When we get to electricity and magnetism, that will be chapter 17, 18, and 19. Right at the end of the course. Okay? Well, let's see what else is going on here. The course is designed to provide the student with not only a basic knowledge of electricity and magnetism, but also an understanding of real-world applications. To prepare a student to understand electricity and magnetism, additional topics include forces. Okay, that's for the rest of the course is. So when you get your book and look at the title, Chapter 5 is forces. So that's where we start, Chapter 5. Work. Jump over to Chapter 8, and you'll see work and energy. We'll work in energy, Chapter 8. So that's where we go next. 8.2, you'll notice, is power. So there's work, energy, and power in Chapter 8. Okay, we'll come back to a thing in a minute. Sound, okay? Sound, that's Chapter 16, wave, motion, and sound. Sonography, sound, that makes sense, okay? Now, there's one other thing here, and the atomic nature of matter. Well, that's Chapter 12, matter. So we won't do it in this order, we'll do it in the order of the book. So basically, it'll be Chapter 5, Chapter 8, Chapter 12, Chapter 10, Chapter 17, 18, and 19. Now, we'll do, let me back off and say this. We'll do basically all of Chapter 5, okay? All of Chapter 8, all of Chapter 12, all of Chapter 16. But when we get to the electricity and magnetism, there's a lot of stuff when they gave more detailed stuff and they don't give it, well, here, okay, it's going to be here, I'm sorry. Atomic nature of matter. Topics in electricity and magnetism include electrical forces and fields, okay? So in Chapter 17, 17.3 is Coulomb's law. 17.4 is electric fields, okay? And that includes forces. The Coulomb's law is the force law, and fields follows that. So it's 17.3 and 4, so that's where we get that. Currents, that's 17.5. Electrical circuits, that's 17.7 and 8. No, 17.7, 8, and 9. We actually do 17.6 because you need to know it for the others. Magnetic forces and fields, that's 18.1, 18.2, and 18.7. Okay? Capacitance, that's 19.5. Electromagnetic induction, That's 19.3. And transformers. And somewhere I left off transformers. Where are they? I think, if I'm not mistaken, they don't have a section called transformers, but it's that's included in magnetic forces, and that's 18.7, I believe, is where transformers are. Got to go back and check. I just taught it last term. I don't remember which section it was in, but it's within one of these sections. Okay, so that's why the sections are sort of picked out like that, because those first few forces, working energy, matter, and wave motion and sound, it sounds like the whole chapters. They're pretty short chapters. Okay, you get through them pretty quickly. When you get to basic electricity, in those chapters you have maybe 5 sections, 6 sections, okay? Pretty short. Basic electricity, 13 sections. So we can't do all of those. So we pick out the ones that they listed here. Magnetism, 7, and we do 3 sections there. But then there's also 19 is inductance, which they mentioned here, and capacitance. So those are the 2 sections we do there. All right. So that's how this breaks down now. I'll go over this again in a minute. But that's the course description. This was just written for this sonography course. So that's pretty much what they want us to teach. Prerequisite says it is required by the program. Basically, that means there is math involved, but it's not super complicated math. I think if you've had Math 098 or its equivalent, you're in good shape. I think it's, math is pretty simple. But it does require math. Now, it's a great idea to have a calculator that will do not super complex things, but more than just add, subtract, multiply, and divide. Okay? Exponentials, powers of 10, scientific notation, that would be a great thing to have. Now, I see a phone on the desk there. Most of your telephones do have calculator mode that will work. Okay, so I think you'll be okay with that. All right, the textbook, as I was just holding, and I just set it down too soon, is this one. And again, we chose it just because this is what Wallace Hansville used, and it does seem to fit the bill. You can find all those topics there. It's Ewan, Schroeder, and Gunderson. Okay, Applied Physics, 11th edition, 2017 is a copyright. Now, I don't know if y'all are familiar with textbooks, but they do change they update editions just about every 3 or 4 years. Sorry about that, but the reason they do it, the publishers only make money selling new books. They don't make money selling used books. So they don't want to keep one edition out there too long, because then they're not getting any new income. So then they have them change editions. Most of the time, the only change is the cover and a little bit of coloring on the pages and stuff like this. The content hardly ever changes at all. Okay? Because the physics hasn't changed in 3 years, so, but they do that. It's a rip-off. That's part of the system. Okay, students are expected to bring the textbook, paper, and a pencil to class each meeting. Now, the syllabus said pencil. If you prefer ink, that's fine with me. But when I do math, confession time, I tend to make errors. So I like to use a pencil, but you can use whatever you like. But do bring your book, because we're working out of the book. And this book does a little bit of explanation and then lots of examples and problems and problems. So we're going to be working problems and problems and problems. Now, on the screen, here's the thing I don't like about the book. The PowerPoint stinks. I mean, it's awful. Okay? Maybe 2 or 3 PowerPoints for the whole chapter or section, or something. It's really pathetic. Well, there's a few more than that, but it's really bad. You'll skip pages without a single PowerPoint. So I supplement that with PowerPoints of my own. Not that they have anything on them, but this computer is a tablet computer with an ionizing pen. Have any of you ever signed out of Home Depot? Okay, you know how great those pens are. That looks just like your signature, right? Yeah, this is a little bit better than that, but not a lot. So I'll be doing a lot of the working through the problems on the blank screens, which I have. Okay. So bring your textbook and paper and writing utensils to class each week, and probably calculator, because you will be needing them. Okay, all courses, I don't like this paragraph, but they require us to say it. All courses must use Blackboard. Let me get it down so you can read it all. Okay. Must use Blackboard to gain access to vital course information such as the syllabus, handouts, PowerPoint shows, activities, assignments, announcements, and so forth. Okay. Time out. I don't have the syllabus updated yet. I sure don't have Blackboard ready because I can't even put the syllabus up there until I get it right. Okay. Sorry. I will, as soon as I can, put it on Blackboard. Okay? I will put the pathetic little PowerPoints out there on Blackboard too, but you'll see they're almost worthless. Not quite, but close, okay? Now, handouts. Most of the time, if I have a handout, I will be handing it out to you. So there won't be any handouts that I put out there on Blackboard, okay? Activities. Sometimes the school posts activities on Blackboard. Those will be the only ones. We won't really have any. Now, assignments. Remember I said we're recording? So every time we get to the end of a section, there's some problems there. I'll tell you right now, do the odd number exercises, or some of them. You don't have to do them all, but some of them. Why do I say odd number? Those answers are in the back of the book. Okay? So every time we get to the end, I'll say that. So yes, it'll be on Blackboard, but it'll be through the YouTube videos. You'll have to go through the videos and listen to hear what the assignments are. But look, you know what they are. If you got the book, if we finish the section, it's those odd number exercises and any that you want to. It's up to you which ones you do. Okay? But it will be technically on Black. I don't sit down and type out an assignment every day. Okay, yes?
How much time are you giving us to get the book?
Say this one
How
more
much
time.
time are you giving us to get the book?
Whatever it takes. You got a week before the next class, but if you get it in that time, fine. If not, you can look on somebody else that does have it.
If you order it off Amazon, it may not take long. I ordered mine last Saturday and it came Tuesday.
Are you on Prime or are you just Amazon?
Okay.
Amazon is amazing. In fact, I think I heard on the news this week, maybe yesterday, Amazon passed Microsoft as the #1 tech company in the world as far as things. It had been Apple and Microsoft back and forth. I think Amazon passed them for the first time. They're #1. They're all really rich companies, but goodness gracious. My wife, that's why they're rich. No, I didn't say that, did I? Okay. All right. Announcements. Most of the time, that's going to be school announcements. If I do have one, I'll put it out there, but I can't think of many things I'll be announcing out there. I do not like this next sentence. Failure to use Blackboard will severely damage your ability to pass the course. That's such a negative sentence, isn't it? If I were writing this, which they don't let me change it, I would say the proper use of Blackboard can greatly enhance your ability to do well in the course. Much more positive statement and closer to reality, I think. Students should always check the Blackboard announcement page and task pages prior to coming to class. Why? I think you're thinking it might be canceled. Okay, now none of you have been in my classes before. A couple of the baseball players have. You can check with them and see how frequently I cancel classes. Never, if I can help it. Sometimes I can't help it. Usually then I'm not going to have time to put it on Blackboard, you know. So, yeah, I'm going to be here. I may be late. Traffic, trains, that kind of stuff. And I can't get away from my other campus until the earliest. I mean, the class ends at 3:45. I'm doing everything I can to leave and get over here. I have to take down one class, you know, unplug and everything, and go to my office and get, you know, the different books and stuff like this. So I'll try to be here, but I usually don't cancel classes. Okay, so I don't like that sentence either. Okay, so what are the professional competencies and objectives? I'm going to scroll this down so that you can match this with your this thing down here. Okay. All right. Like I said, I'm going to use the book again. Students will solve problems dealing with forces. Chapter 5. Okay. Now, I should have put in maybe the title there. And then we'll have, when we finish chapter 5, we'll have a test. Along the different sections, you'll have the homework exercises for those sections. Now, I have a question for you. Do you prefer in-class test or take-home test? Really? Goodness, what a shock. Okay. I didn't see that one coming. Just kidding. I'm just kidding, folks. Okay. Yeah, I think it's better to, because then you can get all the resources you need and figure out, and you're not got the time crunch and that kind of stuff. Because physics is not a time issue. Physics is a get the materials you need, work the problems, you know. So that's what I want you to do. Okay, I'll probably will put the titles in here because that seems pretty important. So anyway, dealing with problems, dealing with forces, that's chapter 5. Students will solve problems dealing with work and energy. That's chapter 8. Here we see chapter 8 test. At chapter 8 and then the test. I probably should put, well, okay. Students will demonstrate an understanding of the atomic nature of matter. That's chapter 12, matter. So there we'll have to do the chapter and you can do problems and then the test. Students will demonstrate an understanding of sound. That's chapter 16, wave motion and sound. Students will demonstrate an understanding of electrical forces and fields. That's chapter 17, specifically 17.3, 17.4, 17.5. No, yeah. 7. Okay, yeah. Electric forces and field. Yeah. Okay, I forgot to say after understanding of sound, that's chapter 16. Demonstrate an understanding of electric forces and field. That's 17.3, 4, and 5. Students will solve problems dealing with currents and circuits. That's 17.7, 8, and 9. And those two together will be your chapter 17 test. Okay? Then students will demonstrate an understanding of magnetic fields and forces. That's 18.1, 18.2, and 18.7. And then we'll have the test. Oh, yeah. The students will demonstrate an understanding of capacitance, electromagnetic induction, and transformers. That's where it is. And that is 19.3 and 19.5. Okay? And then these two, 18 and 19, are tested together. Now, part of the reason is there's only 2 sections in this one and 3 sections there. But the other thing is the test bank had very few questions there. So I combined those together and that will be your last test. Now, that last test will be your final test and it'll be your final examination, meaning the same thing. And it will not necessarily be comprehensive because I'm not going to go back and test you on this again. It'll just be that. So in that sense, this is your final exam. Okay? So here's a breakdown of how each student will be evaluated. Chapter tests will be given at the end of each chapter as a take-home test. The lowest chapter test score may be dropped. The average of the remaining chapter tests will determine the grade for the course. However, the one you drop cannot be the last test. Okay, that is your final exam, and that measures what you've done up till then. So don't say, oh, well, I did really well on the first 5, so I don't have to take the final, do I? Yes, the final you can't drop. Okay, so you'll drop the lowest of the other 5. Now, last term we had some issues and we didn't even get to the last test, so we just had 4 tests, and chapter 17 was the last test. Hopefully we'll get to 18 and 19 this time. We got to 18, but we didn't get enough to run a test on it. We had, I can't remember now, it was either weather or some sort of conflict that we missed a couple of classes that we hadn't intended, and we only meet once a week, and that took a big bite out of the term. Okay, now, how will you be graded on those assessments? This is pretty normal. Your 90s or A's, the average when you drop the lowest test, not counting the final, average the rest of them together. If you're in the 90s, you're an A, 80s B, 70s C. Don't go here, okay? You shouldn't, because it's take home. Say with it. Now, you don't turn in tests, you don't come to class, you don't get your test, you could fail it. Now, we'll get to that in just a bit, so let me just run this down here. Some of this will be, let's see if I can. Ooh, too much. Trying to keep a little of that on the same page with this. Okay. Now, even though I record everything, I don't know if you've ever done it, tried it or not, but it's hard to ask a YouTube video a question. Okay. You just can't do it. I mean, you can ask to your heart's content, but it's not going to give you an answer. So to be here in class, that gives you opportunity to ask questions, interact. You don't understand how I work a problem. Where did that come from? How did you go from here to here? What formula do you use? That kind of stuff. YouTube video, you can't quite get that. So try to be here every day. Okay? We only meet once a week, so we're covering a lot of material every night. Okay? Several sections. So hard to miss much of that and still do well on your test. So try to be here. Now, here's why I left that up there. Before, if getting toward the end of the term and it looks like you've gotten way behind, you're not understanding, you're getting frustrated, or you have an illness, something comes up and you don't think you're going to make it. You think you're going to fall in that DF range. Don't withdraw. Okay? Because if you make it, here at Lawson, if you make a D, you have to repeat the course. It's not counted as failing, but it's not counted as passing either, so you have to repeat the course. Certainly an F, you have to repeat the course. A W, you have to repeat the course. So all three of those, you have to repeat a course. I hope that a D or an F is going to hurt your grade point average. F definitely is going to. And only if you have less than a 1.0 grade point average will a D, it's going to hurt. So guess what? Don't get a D or an F, go on withdrawal. Okay? If it looks like you can't avoid a D or an F, take a W. Okay? A W does not affect your grade point average at all. Yes, you have to repeat the class, you have to repeat for those. Okay? So don't mess up your grade point average. Do the W. Hopefully, none of you even get close to that. Okay? But before you do, consider that. Now, it says about financial aid and that kind of stuff. But guess what? Financial aid will pay for your repeater course once, but not twice. You make a D or an F, you got to repeat the course. You do a W, you got to repeat the course. No difference there. The only difference is a W doesn't hurt your grade point. A D or an F does. An F really does. Okay. Makeup work. Now, that's sort of hard to figure. If they're take-home tests, what's the makeup work? Okay. Unless you don't come to class to pick up your test, then you're sort of in serious trouble because we only meet once a week. So that's another good reason to be in class. Now, the tests do come, 16 weeks in the term, right? And what was it? 6 classes? It's 6 tests? That's a test more than, sometimes it'll be every other week. Sometimes it might be 2 weeks in between, but, most of the time only one. So, if you miss too many classes, you can get really far behind really, really quickly. So try to be here. Okay? Lateness policy, I'm going to try my best to be here by 4:30. I won't always make it, just judging from past history and tonight, but I'm going to do my best to get here by 4:30. Now, getting the projector to work by 4:30, that's even another issue, but I'm going to try to do that as well. Like I said, that other class goes till 3:45. That leaves me 45 minutes to shut down one class, pack my bags, and get over here and get this one set up. So it's really tight. Okay, academic integrity. I don't want to read all this. I want y'all to read it, though, so when I do get this out there, please read it. Let's just try to summarize. Plagiarism. Don't do it. Okay? That close enough? Cheating. Don't do it. Okay? Especially for you in the sonography program. If you need this for that program, cheating's not going to do you a bit of good. You're going to get to the point, and then you're not going to know what they're talking about. Okay? And that's true in everything else too. Okay? Now, professional decorum. I guess this is worth putting something in the syllabus about, but I almost want to sing M-I-C. No, I won't sing that. Okay. I don't want to make too much light of it either, because it is sort of important. Especially on number 2, sleeping here, especially if you snore loudly. That disrupts everybody, so don't, okay? Eating or drinking, I don't know. Some of you are coming from work, you work a full day, and maybe you're just running low of energy. I'd rather have you here alert, so if you need caffeine, have some caffeine. I mean, I'd rather that be than the other case. So, but, in general, don't do anything to distract for other students. Okay? So, we'll do that. Now, that's all stuff that you have to watch out for. This is stuff for me to watch out for. If you have a concern, either I'm not getting this material across to you, not here, whatever, if you have an issue, talk with me. Okay? Let me know. Okay? We'll try to work it out. Second, see the department chair. Oh, I'm the department. No. Actually, Dr. Tracy Wilson is the Natural Science Department chair. Or you can see Dr. Marable. She's the Nursing Department chair. That sort of falls under nursing. So you have some other avenues to go to. You don't have to go through me again, but you can if you want to. Third, let's go on up to Associate Dean, which Dr. Marable is, she's either assistant or associate dean. Dr. Pruitt is associate dean. The dean is Dr. Davis. Vice president is Dr. Crawford. President is Dr. Ward. So we'll work our way up until you get a solution. We want you to be able to learn the material and do well and move into the sonography program with the knowledge you need or whatever. Okay. Boston State website has more information on complaints if you have complaints. Okay, statement on discrimination and harassment. Now, this is no laughing matter at all. I've been here, not on this campus, but I've been out on the Bessemer campus pretty close to 22, 23 years, something like that. I lose track of time. And so far, I have seen basically none. Now, that doesn't mean it hasn't happened. I hope it hasn't happened, but they just haven't been dumb enough to do it in front of me. Okay? But I don't want it to happen. We don't want it to happen anywhere on either campus. So if you see or sense, even think something could be going on, discrimination-wise, harassment-wise, I include bullying, that kind of stuff, please let us know. Please let me know. We want to nip it in the proverbial bud. Okay? We don't want it happening here. We want you to be in an environment where you have ability to learn to your greatest potential. So, State Board doesn't want it. Nobody wants it. Okay? Americans with Disability. As I've already said, I'm hard of hearing, so I'm a little sensitive to this. If you have any kind of learning, reading, hearing, vision, physical disability, let us know. Don't let me know. Dr. Renee Herndon on the Bessemer campus, or Miss Janine McCoy Jones over here in the Space Center, on the Leon Kennedy Center, on the Birmingham West Campus. Let her know. Bring her the paperwork and documentation. They will let me know what I need to do to accommodate you. We'll do whatever it takes. We want you to be able to learn this material. Okay? Yes?
I was wondering, how would you like to be addressed? I know last semester in my class, a lot of students were just addressing the professor by hey, so.
Okay, I answered a hey, okay. Yeah. Straw will work, you know. I mean, I don't care. I'm really not too big on that. So whatever you want to call me. Hey, you, that'll work too, you know. So, okay, yeah. That's not a big deal for me. It may be for some people, so I don't want to make too much light of it, but I really don't care. I ask what you want to be called because I just as soon call you by that. If you would prefer to be called Miss or Mr., I'll be glad to do that. So let me know that too. Do you feel more comfortable that way?
No,
oh, okay.
I'm fine. I just want to know because some people prefer to be called doctor.
Right.
So
yeah. Well, I do have an earned doctorate. It's not a medical doctor. It's a PhD, but I'm not a big deal on that. It's got me the pay that I need. So whether you call me that or not, I'm still going to make the same money. So I'm sorry if I make you too light. But yeah, I understand. Some people are really, really, you know, that's important for them. And if it is you, then by all means, if you want the others to toe the line, I'll say, yeah, toe the line. You know, I'm okay with that too. All right. This is not this college calendar, but it looks very similar. This is last term. You can go to the Lawson State webpage and look under academic calendar. You'll get it on calendars, January, February, March, April, and May. So you'll see exactly what's there. I will get this fixed hopefully in the next day or two, and it'll be out there. But the same things are here, or almost the same things. And then when finally I get the syllabus done and out there on Blackboard, I'll let you know, and then you can either type your name in on this last page and type the date in and email it to me, or you can print it off and sign your name, and if I can't read it, print your name, and then give it to me, just that you understand. So what you know so far, mostly it's just small details. The overall thing is out there like you've seen. Any questions on the syllabus? Okay, good deal. So when this gets out there, if you'll print off that page and sign it and print it and get it to me. Okay, that's it for the syllabus. Another thing I'll put out there is my locator card. And I don't have it done for this time, but I'll show you what it looks like and just fill in the blanks. A lot of the courses are sort of similar, time-wise and stuff. I'll point out the differences. Well, it flashed up and disappeared. There it is. Okay. This, of course, is fall 2018, so it's not correct. But let me scroll down as far as I can. Okay, the top part of that stuff you already know. My name, the phone number on the Western campus, Birmingham campus, and that's Friday only for Birmingham. Is there a question? My email address, and generally mathematics, so that in this case on natural sciences. Okay, I'm usually on campus every morning, usually before 8. Definitely try to be there by 8. And by the way, I don't know if y'all are aware of this. Malfunction Junction and a lot of the area there, before the end of the month, they're going to tear a lot of that completely up. And it's going to be out of commission for, what, a year and a half or something like that. So that may change my arrival time because I come through there and go home there every day. Now, I do have some alternate routes, and I'll try those, and as long as they're not too congested, hopefully I can get there in about the same time. But it could be hectic, okay? So I'll try to be there by 8 o'clock. So right now, doing okay. Okay, and I'm in the office, and again, it's 265 on the Bessemer campus, and PHY112 on the Birmingham West Campus. I've lost this course. I had it this morning. I've lost it now. It says 8 to 10. Okay, so move this down here. Yeah, 8 to 10, office advising. And then at 10 o'clock, I'm in Cal 1. That's 125 now for this term. It goes until 11:40. Then I'm in the office there from 11:45 until 12:30. So this course has moved down to 12:30 now. I've tried to get a little bit longer lunch hour, 45 minutes rather than a half hour. So this is down here at 12:30. It goes 12:30 to 2:10. So at 2:15, I'm back in the office until 2:30. So 15 minutes there, 20 minutes, something like that. And then I have, this is Cal 3, that's differential equations. And that starts at 2:30 and goes until 3:45. And then from 3:45 on, office hours till 6. Tuesday and Thursday, Math 112 at 8:30. I'm in the office at 8:30. Math 112 at 8:30. Math 113 at 10. Now I've picked up a linear algebra class, Math 237 at 11:30. It goes to 12:45. Then I have 30 minutes for lunch. At 1:15, I have a physical science class, and that goes as the mini-term class from 1:15 till 3:45, and then the lab goes 3:45 till 5:45, both days, Tuesday and Thursday. So that's Tuesday, Thursday. Wednesday, just like Monday, except for coming down here at the bottom, and Friday is going to be 8 to 12. Now, they require us to put our lunch in there. Usually I don't take an hour for lunch. On Friday, I usually just bring a snack in, and it doesn't take me very long to eat it, but I'm in the office. In fact, most days I'm eating in my office, so you're welcome to try to call at those times too. Let me scroll this down, and you see on Wednesday, now this is wrong. I mean, this was second mini-term of last term. I couldn't start this class until 3:15. Now this is all moved up to 1:15. And so this is much earlier. I leave at 6, Monday, Tuesday, and Thursday. But here in this class, I travel from there to here between 3:15 and 4. Hopefully get here before 4:30, set up the class, get going, and then it ends at 6:30. So I'm off at 6:30 on this day, off at noon on that day. But most of the time on Fridays, I'm there passing it. If you want to try calling, you can. Okay, any questions on locator card? I'll get this updated. That'll be on Blackboard as well. Are y'all all familiar with Blackboard? I didn't ask that, or did I? Okay. So now they've changed Blackboard a little bit from what it was last term. Last term they had a whole bunch of blue tabs that you had to scroll down. Now they have them in groups. And in the first group, they have course information. That's where the syllabus will be. It's not there yet. Then they have instructor information. That's where my locator card will be. It's not there yet. I've got to get it changed, and then it'll be ready. And then you go down to the next group, and there's something there called PowerPoint handouts and more, or something like that. That's the place where I'll put the PowerPoint the sorry little things they have here for PowerPoint, and basically that's about all that I put in there. Okay, it has been and that's right. Yeah, I'll put the YouTube videos there. The link to the YouTube videos will be there too. It's not there yet, but it will be. Okay. All right. Enough of that. All right. Now there's one other thing we've got to do, and I don't have anything projected for this, but this is required, a good idea, and it's safety. Okay? There's 3 areas that we need to keep in mind for safety. Can anyone think what one of those 3 might be? I mean, we're just sitting in a classroom and watching PowerPoint and stuff. So what's the worry about? Think big picture, huh? I'm sorry? Okay, yeah, that's in case of fire or chemical spill or smoke or something like that. And guess what, team? Were any of you here at the end of the last term? The B building? They had a fire in there. They had an explosion in there. Now, what they think happened, this is what I understand from what the fire marshal's report was, that the woman in the office down on the ground floor of the B building had a space heater under her desk. And it was over next to the filing cabinet, metal filing cabinet. And evidently it was going pretty hot and heavy, and I don't know if she realized it or not, but in that bottom drawer were 2 aerosol cans, maybe more, but 2 aerosol cans. And one of them got hot enough it blew the top off. And unless her drawer was open, it must have blown the top through the file cabinet and into the ceiling. And ceiling tile dust and everything else came down. Loud noise from that, and either the ceiling dust or the fumes that came out of the can when it exploded or something, or just the shock of that explosion. They said she wandered out of her office and was sort of disoriented and stuff, and a couple of others heard it and came out into the hall, saw her, went down, and she was having trouble breathing, so they got her outside. About the time they got her outside, the second can exploded. This was an explosion. They said it was a fireball. And she hadn't picked up her purse or anything else. They said you couldn't find much evidence in the purse. It was vaporized or burnt to a crisp or something. So it was pretty bad. So yes, we need to always keep in mind, what do we do in case of fire? Now, it's not likely it would happen in this room, but what if it did? What if my computer just decides the battery overheats and it explodes and sets my papers on fire there, the book on fire, the desk really can't burn? What do we do? What would be your procedure? What would be your thought process there? Yes. I'm sorry? I think he said run as fast as he could. Is that right? Okay, now that's not a bad thing to do, especially if you don't care about the other people in the building. And choking to death on the fumes. We don't care about them, do we? I think of them as their teammates, okay? So we need to do something before we run. And we don't run anyway. We move quickly, but we don't run. Say again? Fire alarm. Where is the closest fire alarm? Oh my goodness. Anyone notice on the way? Oh, looky there. You see? Right there on that wall. That looks like the closest one to me. Yeah, there it is. So it's really quick. One of you get out there and pull the fire alarm. What else would we do? Second. Now you're running for that. No, okay. Close. Y'all would be in the process of doing so, but I don't usually bring my cell phone to class. Okay? Well, yeah, I will be. It'll be in my coat pocket. But I'll be trying to deal with other things. So one of you pull out, you got your cell phones out anyway. I didn't notice it in this building, but I noticed it on the Bestman campus. The door I usually go in, they have a piece of paper there with emergency numbers. The number for Bestman campus and the number for Birmingham campus, the police number. If I were you, I would program that into a speed dial on my phone and pull that thing out and dial campus police. One person's running to pull the fire alarm, another, at least one, is calling the police, telling them in the Ethel Hall building on the East Campus, computer exploded in the classroom, arcing and sparking, smoke and fumes. They need to know, okay? Because you see, they're mostly over there. They sometimes are over here, but they may be over there at the time, and not anyone on this campus. So call campus police, okay? So we let people in the building know. We let people, the campus police know. They'll get the fire trucks here, okay? They're probably connected to the fire alarm anyway. So then we make a very orderly exit, okay? Now, where do we go? Well, we have some options here, okay? Do not get in the elevator. We're on the ground floor. How are we getting the elevator ready? Yeah. There's an exit that way, and there's an exit this way. This is closer. So I would go to the main lobby and head that way and go out. And generally the rule is, I don't see any directions in this room. Let's see if they have any. I have in the classroom I usually teach from, but I don't see anything here. Okay. They usually say go at least 75 feet from the building. That's in case there's an explosion, glass is blown outward, get away from the building. What I would suggest is let's go across to the parking lot across the way there, okay? Now, if it's super cold, rainy, or something really miserable, go to the closest building that's not on fire, okay? And we'll go there, okay? Now, I'm going to be the last one out of the room because I want to make sure everybody's ahead of me. So here's what you don't do. And I grab my roll book when I go because when we get out there, I'm going to call roll. If anyone's missing, myself or some fire professional is going to have to come back into a burdened building looking for you. So that means do not say, hey, building's on fire, I'm out of here. Well, don't say that. No. We wait until we make sure everyone's accounted for. Then someone will come around and say, look, it's no more classes tonight, head on out of here, whatever. But we wait till that. Now, if it's cold and miserable outside, we go to another building, we wait there until we've heard. Okay. Now, we did leave out one thing. We're just letting the room burn off. Right? We don't want to do that. What else might we need to do? We did a fire alarm, but what? Fire extinguisher. Where is the closest fire extinguisher? Within reach of where I'm standing right here. There's the fire extinguisher. You can't get it much closer than that. It's just heading that way. So one person's going to pull the fire alarm. One person went out to get it. I know some of you guys have always wanted to break that glass, haven't you? Maybe you gals too. I don't know. That'd be so cool. No, the guys I know. Yeah, okay. Well, somebody go get the fire extinguisher. Someone pull the alarm. Someone call the campus police. Or if you don't have that, 911. Okay? One or the other. And then the rest of you, in a very orderly manner, go out the building, into the parking lot, or to the nearest building. But watch for the rest of us, because the rest of us are coming. I'll handle the fire extinguisher, unless some of you really like to do it, and try to get that taken care of. And then I'll be coming, bringing my roll book, and be there together until we get there. Okay? Any questions? All right. That's one type of emergency, fire. That could also be smoke. It could be chemical spill. It could be anything that we need to get out of the building. Okay, now if it didn't happen in this room, we hear the alarm go off, we just take off and go. Nice and orderly, not running. Okay? But nice, orderly, exit out of the building. We account for everybody and go. All right, another type of emergency. Fire. What time of year is this going to be? Second? Tornado season, you're absolutely right, or any severe weather situation. Now, I haven't been on this campus that I recall hearing the alarm, but I bet you hear it pretty well, don't you? Okay, it's pretty. Now, I'm hard of hearing, so y'all may hear it before I do. If you do, what do we do if there is a weather emergency? Where do we go? Where do we go? Do we go outside, get in the car, and go home? No! Last thing you do is get on the road. Okay? What you do is get lowest floor, we're there. The interior, we don't want to be around the window. Limbs could come flying in the window. We don't want to be here if that happens. So lowest floor, interior. Now, where would be a nice, safe place to do that? Well, there's a door going to the outside, but there's no glass here. So this is not a bad area here. And actually, one of the strongest areas would be the exits where the stairwells are. Stairwells are usually really well constructed. as long as there's no glass. So there's a stairwell here, there's a stairwell there, or that little nook right over there. Any of those would be fine. You don't want to stay in this classroom. Okay? So there's plenty of places to go, but gates stay together. Again, I'll be the last one out. I'll take my roll book. We account for everybody, and we wait until we get all clear. Okay. Fire, internal problem, we get out. External problem, weather, we get low in interior. We're already low in interior. What's next? There's one more. Sad but true. Didn't used to even think about it. Active shooter. Okay. Now that's the one that bugs me the most in this building. Okay? The building on the Bessemer campus, I can lock that door. This one, I don't have a key for. Okay? And when I mentioned this to Dr. Marable, she said, well, just put something against the door. Now, we have to lock there, but I don't have a key. She said, put something against the door. I said, Dr. Marable, it opens out. She said, oh, that's right, it does something. So here's what we do. We would close the door. We turn off the lights. Somebody, as soon as you hear the pop, 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 and by the way, you'll hear it before I will. I'm hard to hear it. So if you think you're hearing firing going on, then somebody get right on that Lawson Police or 911 on it immediately. As soon as we make that call, tell them where we are, where we heard, we turn phones off. We don't want them ringing. We don't want them buzzing. You can have them vibrate maybe, but we don't want any noise. Okay? Now, this is the best I figured out to do, because you can't do anything to keep them from coming in. What I suggest that we do is take these tables and put them upright, like this, against the door, one after another, after another, after another, and then if wherever that comes to, then I or somebody else, probably me, will be here against these, because that's going to be enough things to keep them from being able to fire through. And the rest of you, and that way, even if they come in the room, they're going to have all these tables to go through. The rest of you, I would say normally, get here. Okay? The trouble is, this is sheetrock. And that's not great protection. But where else can you go? Anywhere else you'll be visible from this window here. So,
let's jump to the window.
What's that?
Let's just go out the window.
Okay. Well, the firing, if it's coming from outside, that would be safe. If we know it's coming from in the building, then out the window is our best exit. Okay? In the direction further. So if it's coming from that way, we go this way. Coming from this way, we go that way. But if it's coming from outside or we can't tell, then we become targets. Yeah, I think that the screen, I think, is just going to have to go through it. Okay. First person. But the windows, I think the windows, I think, will open. And we're first floor, so it's not going to be too bad. Okay, I don't think. This is out of sight, but it's not. They won't know that we're over here, but so I'm, I don't know. It's a bad situation because there's no way to lock it. Okay. But maybe the other thing, and this might work too, is lay as many tables as we can upright that way, and I'll be there holding them in place as much as I can. The rest of you get the tables and lay them down this way. You're behind the tables. Okay? On the floor, out of sight, out of mind. Now that's if it's in the, if we don't know where it's coming from, that would be probably safe. But you see, people can look in the windows too. We have lights off. If we're out of sight under the tables, the ground is right there. And I think you have to open this way, so there's two hooks here, and I think this, I don't know. I say go through the screen. You can open these and open the window this way. Yeah, so I don't know. Maybe this makes the screen off. Well, we'll figure it out. Pretty quickly. We
just pray and don't let it happen.
And But the thing is that unless we know it's not, the gunfire is not coming from outside, that's okay. But if we don't know, that I would hesitate going out the window. Okay, but we get low, unobtrusive, lights off, quiet, and block the door as well as we can. Sad situation, but there's only been one shooting I've ever heard of on a community college campus. It was nowhere close to Alabama, and hopefully we're not going to have any. Now, some of the major universities have had them, a few, and none recently that I've heard of. I know West Virginia had one, didn't they? Or Virginia Tech or someone like that. And there have been a few, but not that many. So hopefully it will never happen here. But if he should make it into the room, you don't be the hero. Most of my life is back there behind me. Yours is ahead of you. So let me confront him if there's going to be any confrontation. If I can get him on the ground, you're welcome to kick him to, as much as you can. But don't put yourself in harm. Okay. Enough of that. Okay. Now, let me get this out of there. Okay. Oh, there it is. All right. Now, let's actually get to some physics. Sorry, we don't have much time, but we got a little time. Let's do what we can. Any questions on any of the issues? Syllabus, locator card, safety, fire, any of those? Okay. I'm sorry? Okay. Shoot. I would say shoot, but no, never mind. Okay.
I live in the dorm.
Yeah.
This class started at 4:30. That's what time the cab open, and then they close at 6:30. So
That's what time what?
the cab open from 4:30 to 6:30. That's the window.
Really? Okay. So if you need to go to get something to eat, yeah, head out. That's why I record everything. Okay. I wish I'd have known that last term because the basketball players made it seem like it opened 15 minutes after the class started because they were out of here. No, I'm just kidding. Okay. But, yeah, if you need to go. Now, do you have to go over to West Campus? So, yeah, I don't want you to starve to death, faint on the way. So, if you need to go, go. What's that?
I said, you said it's recorded, so I can.
Okay. All right. Here you'll see how totally bizarre our... Oh, I need to do one more thing. Let me make sure I can do that.
When will you put this on?
What's that?
When will you put this on Blackboard?
It's okay. Have you got Blackboard up right now?
I'm talking about the YouTube video.
Okay. It's going to be under the tab that says something like PowerPoint shows, handouts, and more, or something like that. It's when? Okay, I'm going to try to get everything done tomorrow if I can, but I probably won't be able from the hospital to put it on Blackboard, so it'll probably be Friday before I'll be able to put it on Blackboard. Okay. Yeah, okay. This is Chapter 5, Force. And let's see, get the slideshow. Oh, I need to open this too. This is the page that I work from. Okay. So, I know that most of you don't have books, right? So I'll try to keep it as general as I can. And like I said, pretty pathetic PowerPoints here. But let's go from current slide. All right. Chapter 5 is force. That's a picture. That's your cover of your text, and it's something like it at the beginning of most of the chapters. Just a nice picture. I think it may be San Francisco Golden Gate, but I'm not sure. I believe it is. Not sure. Okay. This first figure is on the second page. There's a little bit of stuff we'll do before we get there. So let me minimize this and go to this one. Okay. Blackboard is really slow. Okay. Now, good question would be, what is a force? If you had to give an answer, what would it be? All right, here is about the simplest, huh?
Something that pushes against it.
All right, excellent. Okay. I had physical science when I was in the 9th grade, and the teacher for that was the head football coach. His name was Pooley Hubert. He was old. He talked just like Bear Bryant, and I think he was just as ornery or worse than Bear Bryant. His football teams were the survival of the fittest. He was rough. He was old school. And I remember him talking something like this, and he said, a force is a push or a pull. So you had it, a push or a pull. That's a really simple but exact, a really good definition of a force. Something that's pushing or pulling on something. So a force is any push or a pull. Okay? Now, let's back up and do a couple of more concepts. This is just to sort of get the idea in. First concept is going to be, it's a pair of concepts here. One is going to be a distance. Okay? A distance is from there to here. Okay? A distance. Usually measured in feet, inches, yards, miles, meters, centimeters, kilometers, furlongs, just any kind of thing, okay? So that is a distance. Something very similar to that will be something we call a displacement. When I go from here to here, I go a certain distance, but I go in a certain direction. If I go from here to there, it's the same distance, but it's in the opposite direction. So if direction is involved with it, you have what you call a displacement. Okay? A distance, just a number, that's a magnitude, okay? That is what they call a scalar quantity. It may have a unit associated with it, like feet or inches or miles or whatever, but it's just a distance, okay? Just a number. Displacement, however, is a number in a given direction. When I drove here I didn't drive here. When I went to Bessemer from home this morning, from home to Bessemer this morning, I drove about 20 miles to the southwest. That's the displacement. 20 miles would be the distance. 20 miles to the southwest would be the displacement. Now, if I were driving back, like I did last night from Bessemer to home, that would be 20 miles to the northeast, okay? If it's got a direction with it, that is a displacement. Now, the difference between those two quantities, they're measuring sort of the same thing, is one is just a scalar quantity, a magnitude only, that's called the scalar number. The other, with the direction, is called a vector, meaning it has a displacement with a magnitude with a direction. Okay. Why did I get off into that? Well, here's why. The next concept, distance, the next one is time. For me to get from here to there took a certain amount of time. Okay? Now, the distance divided by time, guess what that would be? Distance divided by time. Think of a distance. Name a distance, a unit for distance. Miles. You name a unit for time. Big unit. Hour. Miles per hour. What do you measure in miles per hour? Time is hour. Miles is the distance. What do you measure in miles per hour? Say again? Speed. Speed. That's what your pedometer tells you. Your speedometer. Okay? Yeah, miles per hour. That's speed. Okay? So a distance divided by time is a speed. Now, if you have a displacement divided by time, that's the velocity. Speed, scalar, just the magnitude. Velocity, vector, magnitude with the direction. Now, in everyday English, we use speed and velocity like they're the same thing. But in physics, velocity is a vector quantity because it has the displacement with it. Okay. Well, what we've just done there, we took a displacement and we did a time rate of change of that. In other words, divided the distance by the time rate of change. And we come up with a totally new quantity, speed, or velocity. Well, what if you say, how fast are you changing speed? Time rate of change of velocity is what we call an acceleration. That's what your accelerator is, right? If you're changing speed really slowly, you're going, if you really stomp it, you know, so that's the rate at which you're changing your speed or your velocity. That's acceleration. These were covered in earlier chapters, so I wanted to hit those now. Okay. Now, why did I bring those up? Well, a couple of reasons. When you're moving, you know you've got displacement, you've got time involved, so you've got velocity or speed. So if you're moving, you've got a velocity. Now, what a force is something that enables you to change your motion. And think of change your velocity. So let's think of this. Okay, I'm just keep putting along here, right? But if I speed up, then I'm accelerating. That's changing. I had to do a force in order to accelerate. Okay, apply a force to change my motion. Let's think of a bowling ball. Okay, if I roll the bowling ball down the floor here, it basically is going to go about the same speed. It's going to lose a little bit because of friction, but basically it's going to go about the same speed unless you stick your foot out and kick it, right? And then it's going to change its velocity, which could be changing its direction or changing its speed. Or you could kick it this way, and then it would speed it up. Again, I've exerted a force that changed its motion, changed its velocity. Okay? That's what a force does. A force is a push or a pull. What does it do? It changes the velocity. What is a change of velocity? An acceleration. Okay. So now we've tied those terms together. A force is any push or pull. Forces tend to change the motion of an object or prevent the object from changing its motion. Okay? That would be, well, that's a rather strange one. A force is a vector quantity, therefore has both magnitude and direction. It tends to produce accelerations in the direction of its application. Okay? All words that we need a little bit of definition, it felt like, for. Now, there was a very, very, very famous physicist who really changed physics probably more than any other individual ever has from the history of mankind. He was a British guy, and you'll recognize the name. His name was Sir Isaac Newton. He wasn't originally a Sir, but it was Isaac Newton, okay? And before him, there was one other whose name was Galileo. He was Italian. And actually, the same year that Galileo died, Isaac Newton was born. That's rather bizarre. It's sort of like they did a cosmic, tag off, they really didn't, but, But Galileo had come up with the first change of way of thinking in a long, long time. Before him, Aristotle was the honcho. Aristotle lived back a few hundred years before Christ, and Galileo was maybe 1400 years after Christ. So that had been almost 2 millennia that nobody questioned what Aristotle said. If Aristotle said it, it must be true. Well, Galileo came along and said, well, let's test this. Let's experiment with it. Let's see if it's true. And he found a lot of things weren't. Okay? And one of those led to the concept of force. So he came up with the first concept here, and what I'm leading to with him, it's called the law of inertia. Now, have y'all ever heard of the concept of inertia? What do you think of when you say inertia? Okay, let me get my pen activated. First thing I've written tonight. Okay, inertia. Okay. Now, cover the last 2 letters and what do you have? Last 2 letters. Inert. Which means couch potato. Okay. Not doing anything, just there. Okay. Well, that's one side of inertia. This podium is inert. It's not moving. It's just sitting there. In order to make it move, I have to exert a force on it. Okay? Now, let's get that bowling ball again. If I did exert a force on it rolling down there, if you're going to try to stop it, you have to exert a force to change it, to make it stop. So inertia could either be sitting here doing nothing, being inert, or moving in a straight line path at a constant speed, and that is also an example of inertia. Okay. Have any of you ever messed around with a pickup truck? Okay. I'll give you an example. I had one up. We have a SUV we use now, but it's not as good as a pickup truck. And I remember my lawnmower had died or was leaking gas or doing something, so I wanted to take it to the shop. So I put it in the back of the pickup truck, in the bed of the truck, and I thought I had chocked the wheels okay, but it lasted about a block or 2, and then every time I sped up, the lawnmower whammed into the tailgate of the truck. If I stopped, whammed into the cab of the truck. If I turned, whammed into the side of the truck, or this way or that way. Why? Because any change that the truck was doing, it was changing the inertia of the inertia of the lawnmower was trying to keep going the same speed. Okay. Have any of you ever traveled on a bus or say in the Atlanta airport on those trains? Okay, you know what I'm talking about?
Yeah.
Okay, if you don't hold on to those bars or straps or something, and that train or the bus or whatever takes off, you're falling backwards. Well, you're not falling backwards. You're trying to stay where you were. It's moving out from under you. Your inertia is keeping you. Or if you're moving along and then suddenly it stops, you say you're thrown forward. No, you're not. You're trying to keep going at the same speed you were going, maintaining your inertia. It's just that the vehicle has stopped. Okay? So that's what inertia is. It's the tendency to maintain a state of motion. The tendency to maintain a state of motion. So, actually, Galileo was the first one, but this book gives more credence to Isaac Newton, though Galileo actually did it first, and Newton followed up with his, and this was the first law of motion. Now, Galileo is the only one he really messed with, okay? But Isaac Newton took his concept and expanded on it and made it his, what he called the first law of motion. And this is what it was. A body that is in motion continues in motion with the same velocity, speed, at a constant speed in a straight line, and the body at rest continues to stay at rest unless an unbalanced or outside force acts on it. So this thing is going to sit right there until I try to move it, someone kicks it, someone does anything, something to change its motion, exerting a force on it. or that bowling ball is going to continue rolling in a straight line until someone kicks it, moves it, pushes against it, or speeds it up. Okay, but it's going to travel at a constant speed, constant velocity, straight line, constant velocity. Okay. Now, unless it's acted on by an unbalanced force. That's my push, the pull, the kick, whatever. That's the unbalanced force. So that's Newton's first law of motion, and it has to do with those unbalanced forces. That's the law of inertia. Actually, first constructed by Galileo, but Newton built on it. So let's go now to this one. Here, the poor old guy, well, let me blow it up here from current slide. Okay. Pushing against this, whatever it is, big old box or whatever it is, maybe a tabletop, I don't know what it is. He's pushing against it, trying to get it to move. Now, I can't tell now if it's actually moving or not. It may be, but if it's not moving, I guarantee you one thing. That guy can tell. It looks like he's pushing. Now, I'm going to push on this table here. I am pushing. You can tell, the color of my hand. Yeah, I am pushing. It's not moving. Something's pushing back on me. So it's maintaining a state of motion because there's no unbalanced force. The same force I push there, the wall's pushing back on me. Okay. Now this one is not against the wall. Okay. I got it to move because I was an unbalanced force. I made it change its state of inertia. Okay. So that's what we're talking about there. Okay. This guy pushing against this, if he's not moving it, like I wasn't moving the first one, whatever force he's pushing with here has to have a balanced force here to maintain its state of inertia because it's not moving. So this force must equal that. Now, if he pushes harder this way, then the friction down here, that's what the resistant force is friction. If he pushes harder, then it is going to move. Just like when I push, and you might not have seen it, I'm pushing a little bit, I'm not doing anything. Push a little bit more, still nothing. Push a little bit more. Finally, it moves. Okay? I finally overcame that resistive force there, so my push was a little bit greater than that resistive force, so then it moved. That then is called an unbalanced force. When they have the same balance, when one of them's stronger, unbalanced, that's what created the motion. Okay? So, I'm trying to get pants too. Okay, never mind. Okay. So the pushing force and the friction force cancel each other out, resulting in zero acceleration. No net force. Okay? Certainly there's forces. A pushing force this way, a resisting force that way, but no net force, so you have zero acceleration. Okay. Oh, where did the little book go? Okay. Now, wow. The second slide here is pages away. Okay. Terrible PowerPoint. Okay. So let's go back to my other one. Okay. Go from current slide. Okay. Now, let's imagine, now I don't draw very pretty cars. Okay. Let's imagine the car. Let me get my pen color back. Okay. Okay, let's just imagine that's a very sporty car. Yeah, right. Okay. And it's traveling down the road in this direction. Okay. Now, ooh, that's ugly, isn't it? There are some forces against that car. Certainly there's a friction between the tire and the road. If you don't believe there's friction between the tire and the road, after you've driven a long way, reach down there and touch that tire. It's hot. Okay? Even on a cold day, it's going to be warm. Okay? Because there's friction between the tire and the road. If it's traveling, especially traveling very fast, you have air resistance all along here. That's friction. That's actually a form of friction. Okay? Now, if the car is propelling forward, if you're going at a constant speed, guess what? The push of the car on the road is equal to the push of the road on the car plus the push of the air on the car, so you're going at a constant speed. There's no net force acting on the car if you're traveling on cruise control. Okay? No net force because you're not accelerating. No acceleration, no net force. Okay? Now, let's say that wasn't the road. Let's say this was a perfectly flat, slick ice field, and the car's on that. Okay? Now, number one, you're not going to be able to get the car to move anywhere because the tires just spin. And you can actually go over there and push on the car, on the side, on the front, or anything else, and you'll probably get, as long as you got spikes on your thing so you have something to push against. In fact, do you remember the snow apocalypse or whatever they called it that happened in Birmingham? What was it, January or February, a few years ago? And where that sudden snowstorm came and then everything turned to ice and nobody could move anywhere. I had, it was really a bizarre day for me. I had been at the Kirkland Clinic and for a visit with my hematologist. I have a mild form of leukemia, so I have to see a hematologist, and it happened to be the only time he sees patients are Tuesday mornings. It was a Tuesday morning. I was there, and I was working on I had my bag under my chair, working on things. I had left something in the office that I needed to work. And I got mad at myself and, sort of mad and it swooped down. I did something and got my heart out of rhythm. The bending over and doing, what's that? What's that?
I don't want to see you on my floor.
Oh, okay.
I work on a cardiac floor.
Oh, really? Yeah. Well, it was what they call, it's not an arrhythmia. It's, I can't remember the term he used. It was not a heart, something. It was heart flutter. And, Dr. Plum. Vance Plum. Yeah. They go to our church. And, so, that's who I saw ultimately. But I just had this heart flutter. It happened 2 times before. It happens about once every 7 years, whether I need it to or not. But it's always some sort of weird thing that happens with it. I haven't had one in many years now. How long has that been? It's probably been close to 7 years, so maybe one's coming up sometime soon. I don't know. But anyway, I had been there, and they noticed my heart was going weird things. It was always blood pressure low. Heart was very regular, always. And this day it was just nuts. And so they sent me up to Dr. Plum's lab up there in the Kirkland Clinic. And so anyway, I sat around and basically almost quit by the time anyone got to me. But I wondered where people were. I needed to call the college because it was a Tuesday morning. And I had a class in the afternoon, and it was taking so long, and I was trying to call. I couldn't get anyone to answer to come on. And I thought, what in the world? I tried every number I could think of. Well, then they said, look outside. And that's when I realized the snow had come. And the school had been canceled. That's why no one was in the office. And I was there, and my wife, finally, I got in touch with her. She said, get home. Because, you're not going back to school now. The campus has been closed. So I went to get in the car. I couldn't get out of the parking deck because everything was ice out there, and anyone on the road was stuck. So she said, go on and get something to eat because it was nearly lunch by then. So I did. And by that time, finally, the parking deck had cleared. So I drove home. And that was sort of interesting. I got to the last hill, and the truck just wouldn't go up the hill. So I just sort of slid into a parking place, backed into it and stopped and then walked across the hill. Just about the time I was inside of the house, on the other side of the hill, going down the hill, my phone went off. I answered my wife. She said, "Can you come pick us up?" She said, "We can't get out either, and everything is just a mess. Can you pick us up?" I said, "Well, I'll get as close as I can." She said, "We'll go through everything." She works at Children's Hospital until she got to Kirkland, so we were going to meet at the corner. So I got there. But when I was on the way back, there was this car going down a hill, and it looked like for sure it was going to slide into the parked cars because the woman had absolutely no control. This big old guy looked like he had been a football player. He was running along next to it, pushing. He would just get against the car something to push and keep it from colliding with the car. And he was able to push the car more than she could control anything. So yeah, you can push even the side of the car if that was perfectly slick ice because there's no friction. Any force you put on it is going to be an unbalanced force because there's almost no friction on the bottom. Okay? So, ugly picture. But anyway, that's what the next one shows. You may have seen some of these little tricks that they do that indicate this. Let's try this. Okay? Now, what will happen if I pull the paper? What will happen to my flash drive?
If you keep pulling it?
Huh?
If you keep pulling it?
Yeah.
The flash drive will end up falling, right?
Falling onto the floor. Okay? That's what you do now.
See, but you did it too quick.
I did it too quickly. Okay, you're absolutely right. The inertia of the flash drive made it so it didn't even notice the paper.
Can you do that on the table?
Yeah, you can do that on the table.
Can you?
Can I do it?
With the tablecloth?
Oh, not with my wife's fine china, I can't. You know, she wouldn't shoot me for even trying. But yeah, if you put cheap stuff on there, yeah, you can do that. I sure wouldn't put her crystal on there. But yeah, you can do that with a tablecloth. Now, you don't want a rough tablecloth. You don't want a hem on it. Then it's going to pull it off. But if you have something pretty slick, yeah, you can do that. And you may have seen that happen before. That's an example of inertia. The inertia of the flash drive made it so I didn't even notice the other because I did it real quickly. Now, if I did it slowly, then the friction, that little bit of friction between that is going to pull it right on off with it. And then it would hit the floor. So I cheated. Okay. All right. Now, here's my ugly little car here. What if I put that next to yes. Okay. It's basically almost time, isn't it? Okay, we didn't get much done, but we got a little bit. We really almost did finish 5.1, so we'll call that quits there, and we'll pick up with 5.2 next time. Didn't have any homework exercises there, but we'll start hitting examples in 5.2, so we'll pick up and go from there next time. All right, any questions? All right. Looks like it's going to be a good class.
Hope so.
And we will proceed from there.